Right, let's go into Python. We will need these images, so I'll swap between them from time to time and hopefully explain and test this at the end of it. So we're going to use functions. Where's my Python? There we go. We're going to use functions to do this. It's just one job, half adder. It's going to add two binary digits together and produce a sum and a carry, and the full adder is going to take three binary digits A, B and the carry in and produce this sum and a carry out. So they're functions. So I'm going to start off just by defining the functions. So the first one is going to be the half adder, and we will use these over and over again. And what I'm going to do is return a value, and I'm going to return them as an array, 2 items. I can't return a single item, so I'm going to have to use an array to send that information out. Then I'm going to define my full adder. So this is the sort of design stage, if you want, and again I'm going to return 2 items in an array. Now let's consider how we're going to call these. So here's my main program. Starting here, I would have result, which would be an array of 2 items, and that would be the result of calling half adder. And I'm going to do another one, a result equals the result of returning from a full adder. So that's my program sort of working. I could save that now. In fact, I will. I'll save as, wherever that's going to go. There we go, and I'm going to call it adders.py. So my program will run. It won't do anything. I've just outlined what I'm doing, half adder and a full adder, and I've done a call to both of them. So now I'm going to start filling in the details of it. So let's start off with the half adder. The 2 things that we need to go into the half adder are A and B. So I'm going to send those 2 items in, A and B. I'm using lowercase, you could use capitals if you want. And what's going to come out is S and C. Now to be honest, I'm going to give the C its proper name with C out. So it's going to return S and C out. That will make it a little bit clearer when I'm playing around with full adder as well. So there's my half adder. So let's nip on over to the full adder. Let's find my program. The full adder, the inputs are A, B and C in. So I'm going to type into here A, B and C in. And it's going to return at the end of the day sum and carry out. That's why I used C out. So it's going to use S for sum, oops, needs to be inside there, S for sum and C out. So that's my 2 functions defined and returning values. I've still got to write the program in the middle, but basically that's correct. So all I need to do is match the call to this the parameters in the function. So for a half adder, I'm going to send in 0 and 0, 2 binary digits, and for a full adder I'm going to send in 0, 0 and 0. We're going to use these to test it later on, so these will change between 0 and 1. There is no testing or no, what can I say, defensive design here. I'm just testing here. If I put 2 in, it's not going to work. I'm just relying on my testing just from a gut feeling at the moment. Later on I might put in some defensive design and stop any numbers different to 0 or 1 being entered. So let's go back to the half adder and let's do the logic, the bitwise logic for the half adder. So let's take a look at the circuit here. It's got an XOR gate and it's got an AND gate. So what's going to happen is that the sum S is going to be the result of A XORed with B. So A goes in, B goes in, it's XORed, and the sum comes out. And I'm just going to put those in brackets just to make them clear. You don't need them for this particular one, but you may need brackets later. And I'm going to do the same now for the carry out. The carry out is equal to, well, that's just A and B. So I'm going to do A and B. Now I am using bitwise AND. I could use normal AND, but because we're dealing with bits, it's better if we use the bitwise version rather than the logical version. So that is my half adder done. Straightforward, if you understand the logic diagrams. However, the full adder is a little bit different. So let's go on over to the full adder. It's a rather large circuit that we need to take a little bit of care over, because what's happening is that although we get A and B and exclusive OR, there's a kind of intermediate point before I go into the next XOR. So it's not straightforward, but it's not too difficult to work out. So let's deal with the sum first. S equals. So S equals. First of all, we have to do this. It's the only way to S from A and B is through this XOR gate, and that forms one of the inputs to the second XOR gate. So let's do that one, and we did it here. So it's just the same as this. It's A XOR B. And what I need to do once I've got that, the second leg of the second XOR gate, so I'm going to be doing a second XOR gate. This is the first leg of the second XOR gate. What I need to do is XOR that with C in. And that is the sum of the two items. Almost straightforward, not bad, but a little bit harder to think of what was happening. Now we need to do the C out, the carry out, and if you notice we've got two AND gates, then we're going to OR the result. So it's quite a lengthy process, but again, if we take it nice and easy, we will get there. So I'm going to take the A and B inputs. The A goes to this AND gate and the B goes to that AND gate. So we need A and B. So that's this input here, giving me that output there. So what I'm going to do is put that in brackets to show that I've done that. And this input here is the result of this XOR. Well, we've already done that here. Just here. So let's do that one and we'll build the logic as we go. So this one is A XOR B. So I'm at this point here, and the other part of that is so it's the first leg of it. The other part of that is the C in, the carry in is the second leg. So I need to AND that with the C in. So what I've got now is this gate. All of this is this gate. I've got to OR both of these two together to get my carry out, and to OR it I just need what we call the pipe. There we go. So that's the bitwise operator for OR. So I'm going to enclose all of that just in case I need to play around with things later as a whole item. That is the logic for the full adder. If you didn't understand, don't worry too much. You will never be asked to write this. We're just doing it so that we can play around with Python and do addition through logic. So what I'm going to do now is save this, and then we'll go through some testing to see what happens.